Hey guys, it's Matt, and in this video, we'll be talking about thermal energy transfer. So let's get started. To start, you probably heard of this term before, and this term is heat. As it turns out, heat is just a form of energy, and it can be transferred from one object to another. This is evident when you boil water, cook something on the stove, or even just touch the desk. Typically, the heat transfers from the warmer object to the cooler object, like so. So when you touch the desk, your hand would be losing the heat and the desk would be gaining the heat. There are three types of thermal energy transfer: conduction, convection, and radiation. Let's start with conduction. Conduction is when the object is directly in contact with the heat source. Let's see what that looks like. I'm going to draw a cube in red, and this is going to represent a hot cube right here. And I'm also going to draw a cube in blue to represent a cool cube. Now, what's going to happen when we put these together and they make contact is that the thermal energy is going to transfer from, again, the warmer object to the cooler object. So now let's move these together. And now let's pretend that the heat energy is transferring over. So that's going to look like is the heat's going to come from the red cube and make its way to the blue and cooler cube. And because these are in direct contact, this is conduction. And eventually, these two are going to become the same temperature and reach thermal equilibrium. Now let's talk about convection. Convection is when you feel the heat transferred by a mass motion of molecules. Let's think about when you're holding your hand above boiling water and rising into the rising steam. I'm going to erase all this right here. Now let's pretend that this was sort of a pool of boiling water and steam was rising up from it, like so. Steam. Now, if I put my hand over here on top of the steam, it's going to be hot and you're going to feel heat. This is from the convection and the H2O molecules rising up as steam. So, lastly, we have radiation. Radiation is an indirect way of thermal energy transfer in a sense because you're not really in contact with anything. So, let's think about when you're sitting next to a fireplace and you feel warmth. That will be an example of thermal energy transfer through radiation. I'm going to show you guys what that looks like. Let's pretend that we have a fireplace over here. Here's the logs and whoops, here are the flames. Now, when you're sitting from where you are and you feel the heat coming towards you, that's going to be the radiation from the fire to where you're sitting. And that is the radiation thermal transfer of heat. I'm just going to get rid of all of this now. So now that you know the three types of thermal energy transfers, there are actually two types of reactions. Those types are going to be endothermic reactions, or endo, and exothermic reactions, or just exo. We're going to start with exothermic. So exothermic is when an object is giving off heat and thermal energy, and endothermic is when the object is receiving heat and taking in energy. We're going to see what that looks like. I'm going to move exo over here. I'm going to move endo over here. So now let's pretend that we have these red lines representing heat. Exo is going to be giving off the heat to its surroundings, like so. And endo is going to be receiving the heat from its surroundings, like so. And that's the difference between them. So an example for endothermic reaction is when you have an ice cube in room temperature, and that would be endothermic because it takes in the surrounding heat and melts into water. And an exothermic would again be fire. I'm going to get rid of all this real quick. So in higher chemistry, there's a value called a delta H value. And delta just means change in. So this just means change. So the change in heat. And if this value is greater than 0, that means that the reaction is endothermic. But if it's less than 0, it means that the reaction is exothermic. So if I say that a reaction had a delta H of negative 220 kilojoules per mole, which is just the unit, this would be an exothermic reaction. But if this had a positive 220 kilojoules per mole, then this would be an endothermic reaction. So now I'll give you some practice problems to solve and practice on. Get rid of all this. So question 1, is fire burning an exo or endothermic process? And what type of thermal heat transfer is it? Let's pause the video here and write it down, and when you unpause, I'll explain it. So I'm hoping that you guys solve the problem by yourself. A fire burning is an exothermic reaction, and you'll feel the heat through radiation. Question 2. When you're typing on a laptop and your palms heat up because of the laptop's heat, are your palms going through an exo or endothermic process? And what type of thermal heat transfer is it? So let's just say that these red circles represent the palm rest of your laptop, and these are your hands. Are your hands getting an exo or endothermic process? Pause the video here and write out the explanation, and I'll be back. All right, guys, hoping you guys finished and solved the problem. The palms would be an endothermic reaction because they are absorbing the heat, and it is an example of conduction because your palms are going to be in direct contact with the laptop. I hope you guys enjoyed this lesson and learned something from it, and stay tuned for the next lesson. Thanks. Bye.